Hi, today we're going to be looking at the first part of the Triangles and Congruence exam review for Unit 3. We're going to do the guided review sections, and then I'm going to leave the independent practice sections for you to work on your own, and then you'll be able to check the answers in the given key. So my first part says, in the diagram, triangle CAR is congruent to triangle GER. Which of the following statements is or are true in the given figure below? So the first thing I'm going to do is I'm going to use my congruence statement to mark everything I know to be true about the triangle. So I know that angle C matches with angle G. So C and G match each other, which I already know because they have the right angles marked for me. I know that the middle letter A and the middle letter E, I know those angles will match each other. I know the last letter R and the last letter R, that's where these vertical angles come together that I would have known were congruent even without the congruence statement. Okay? Then if I look at my letters together, if I look at the first two letters, CA matches with GE. So CA matches with GE. The second two letters, AR, matches with ER. AR matches with ER. And then my outside two letters, CR matches with my outside two letters, GR. So now let's see which of our sentences or statements are true or false. The first one says the measure of angle ACR is equal to the measure of angle EGR. So let's see where those angles are. ACR, that's this 90-degree angle. And measure of angle EGR, that's this 90-degree angle. That's true. They are equal. Okay. The next one says segment CA is congruent to segment ER. So CA has one tick mark on it and ER has two tick marks on it. These are not going to be congruent. We cannot prove that. Okay. The next one says angle CAR is congruent to angle GRE. So let's see where those angles are. CAR, this single arc angle, and GRE is the double arced angle. So those do not match each other. That is also a false statement. Okay? And then my last sentence here, or my last statement, segment CR is congruent to angle or segment GR. CR has my triple arcs on it. GR also has my triple marks on it. So since they have the same markings, we can say yes, that is true. Okay? All right, so now you'll have the opportunity. You can pause the video and look at these and write your answers down on scratch paper. Or if you've been able to print out, if you have the capability to print out the review, you can mark your answers on the review. All right, let's look at the next guided practice. Segment BD is the perpendicular bisector of segment CA, and BA is equal to BC. What additional information would be sufficient to prove that triangle BDA is congruent to, oh, we're missing part of this, triangle, let's see, BDA, we're looking for BDC. Okay, which is enough information to prove that. Okay, all right, so let's look and see. We want to prove it by either side, 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 by side angle side, or by HL, or by ASA. Let's see what other information we would need. They've already told us we have a perpendicular, that means 90 degrees. So BD is hitting the opposite side at 90 degrees. And if it's 90 degrees on one side, we know it's 90 degrees on the other side. Okay? And it's a bisector of CA. So CA, they've already told us, is being bisected. And it says that BA is equal to BC. BA is equal to BC. So that information has been given to me already. Okay? So let's see what I would still need to say in order to prove by side, side, side. I can already see I have these two sides marked and these two sides marked. So all I would still need to say for side, side, side is I would need BD to be equal to itself, needs to be congruent to itself. And what property is that called when you say something's congruent to itself? We say by the reflexive property of equality. Okay? So that's so that we can get that segment to be equal to itself. Okay? If I want side, angle, side, given just the blue information that I put on here, not the orange that I just put on there. If I want just given the blue and I want side, angle, side, okay, I have two sides. I would need the angle in between them. So if I want side, angle, side, I could say that angle A needs to be congruent to angle C. So angle A needs to be congruent to angle C, okay? And so I would need with more information because there's no way right now to show that without first using something else to prove congruent. Okay? I could have also used the BD on this one, right? Because then I would have side, angle, side. So I could have also said, or I could have used this one again. BD is again congruent to itself by, again, the reflexive property. Because then I would have side, angle, side for the left triangle, and side, angle, side for the right triangle. So again, I could have used that reflexive property of equality. Okay. HL. For HL, if I look at this one, I already have a hypotenuse. Well, I have a right angle, so that's good because you've got to have a right angle in order to have a hypotenuse. The hypotenuse is already marked congruent, and I have a leg already marked congruent, so no other information is needed. We can already prove by hypotenuse leg that these two triangles are congruent. Okay. Okay. And then last one, angle, side, angle. To be able to prove angle, side, angle, if I already have this angle here, okay, and I already have AD and DC, then again, I would want to go back to that angle A and angle C being congruent. And there's no way to prove they're congruent right now without going through one of these other ones and proving that they are congruent and then using CPCTC. But if I want to prove by ASA first before I use CPCTC, then I would just need more information. To be able to show that angle A is congruent to angle C. Okay? All right. So I'm going to do, there's another question right here for our guided practice we're going to go through. Which equation could be used to find the value of x, to find the value of x, what it would be, in order to prove triangle EFG is congruent to triangle EHG by the side, angle, side postulate. Okay, so if I want to prove these two triangles that are next to each other by side, angle, side, okay, I can already see that I have a side congruent to a side because I've got 24 and 24, so I've already got a side. I've got EG can be congruent to itself, so that's my other side. So if I want side, angle, side, I have to be the angle in between them. So it's going to have to be this angle on the right is congruent to this angle on the left. That little 30 degrees up there, that's just extra information. Okay, I don't even really need that little 30 degrees up there. I just need to be able to prove if I can show that 3x minus 10 is equal to 2x, then I could prove by side, angle, side, and side, angle, side that these two triangles are congruent. Okay, so in this one, if I were going to solve this one, the first thing I would want to do is get all my x's together. I usually move the smaller x. This sometimes creates a problem though. When you move the x and it was the only thing on that side of the equals, sometimes we get a little bit lost because we do 3x minus 2x and we say that's 1x minus 10 equals, and then we go, what happens here? Everything canceled out. And again, that's kind of why I don't like saying cancels out, because then sometimes we don't realize what's really there. That's why I tend to put the 0 and talk about how it's 0 plus whatever's over here. We have nothing left on that side, so there is a number there. The number is just 0. Okay, so then I would add 10 on both sides. And this becomes a 0, right? Instead of saying it cancels out. And I end up with x plus 0 equals 0 plus 10. So what equation could be used to find the value of x to be in order to prove triangle EFG is congruent to triangle EHG by the side angle side postulate? Look, I didn't even really have to solve it. It said what equation could be used. That's the equation, 3x minus 10 equals 2x. Okay? All right, take a moment to pause the video. Actually, we're going to go ahead and just pause here, and we'll go a second video to look at the next guided practice. So before you leave, go ahead and write your answers down to these two problems, and then you'll be able to check them on the key that will be provided. All right, and thank you so much for watching.